In section 8.1, we're going to be taking a look at the inverse sine, cosine, and tangent functions. Key word there, inverse functions. And you might be thinking, didn't we talk about inverse sine, cosine, tangent back in chapter 7? For example, isn't the inverse of sine cosecant and the inverse of cosine is secant? Well, those are inverse ratios. If we take sine and flip it over, or in other words, write the inverse, we will have the cosecant ratio. And same thing for cosine. If we flip it over, we will have secant. But we're talking about inverse functions. And the concept of inverse functions we've dealt with in the past, we dealt with in Algebra 2, but maybe just a quick review of inverse functions would be helpful as we kind of lay some groundwork for what we're going to be doing in this lesson. So let me just do a quick little review of inverse functions. Here I have a function identified as A. It's just a real simple set of ordered pairs. I know it's a function because there are no repeats in the domain, x values. There are no repeats. We could go one step further and we could call this a one-to-one function because not only do I not have any repeats in the domain, that identifies it as a function, but I also have unique ranges. Okay, every unique domain number has its own range number, so there is truly a one-to-one pairing, and we call this a one-to-one function. So what that means is for a one-to-one function, when I do come up with its inverse, it also will be a function. Well, how do I come up with that inverse? And here I've labeled it as, it looks like a -1 exponent, but this is the symbol for the inverse of. So if this is A, this means the inverse of A. Well, if you know a set of ordered pairs representing a function, coming up with the inverse of that function is really pretty simple. We just switch the ordered pairs. So instead of 0, 4 from the function A, I do 4, 0 to get the inverse. And I do 7, 2. And I do 10, 5. And I do 16, 11. So you can kind of see an important characteristic that pertains to functions and their inverses. The domain of a function becomes the range of the inverse. You see that? I'll just go ahead and state the range. That's the y coordinates. And that's just going to be 0, 2, 5, 11. So it's always true. I'll say it once again. The domain of a function will be the range of the inverse of that function. And that's also true about the range of a function will be the domain of the inverse, because you're literally just switching the ordered pairs to come up with the inverse. Okay, so that's how we would come up with the inverse of a function and how we would know if the inverse is a function. It will be if we're dealing with a one-to-one function. So that's looking at a set of ordered pairs. Well, what about a graph? Here's a pretty simple parabola. It's kind of ugly, but here's a parabola, and it's a function. Definitely, all parabolas are functions, but is its inverse a function? And well, there's two ways we can know. We can apply what is known as the horizontal line test, and the horizontal line test says that if I can touch two or more points on a function, then its inverse will not be a function. So we can tell that the inverse of a parabola, which is a parabola that lays on its side, you might remember from Algebra 2, we did this quite a bit. Here's a rough sketch of the inverse of this parabola. And if you're looking at the inverse, you can tell that it doesn't pass the vertical line test. So if you want to not have to graph the inverse, you could do the horizontal line test, and that will tell you ahead of time whether or not the inverse of a function will be a function. So it's pretty obvious that the blue parabola's inverse is not a function itself. But what if we say that we're only going to allow certain inputs? In other words, the blue parabola has all real numbers as its domain. Any real number can be used. But what if we say we're going to restrict that and say that only the numbers 0 and above can be used? Well, now we're only going to look at half of the parabola, and in particular the right side, if we restrict the domain in this way. Well, would this be a function? The red would be a function, definitely. It passes the vertical line test. Would its inverse be a function? Well, let's see. Does it pass the horizontal line test? The horizontal line test will give us a preview as to whether or not the inverse of this function will be a function. And I only touch one point instead of two like I did up here, so the inverse of this, since I restricted the domain, the inverse will be a function. So keep that in mind, because that's very important. This concept is very important with what we're going to be talking about with sine, cosine, and tangent. Okay, this idea of restricting a domain so that the inverse will be a function. That's crucial. And so let's just jump right in. All right, now we're up to more current stuff. We looked at the graph of sine, cosine, and we didn't actually do the graph. I think I showed you tangent, and I'll show you again in this video. But let's just take a look for just a second at the graph of sine. Here's the sine function. You guys know it well. You did it on your last test. Is the inverse of sine a function? Well, according to the horizontal line test, we'd have to say no, because you can tell I'm touching a lot of different points on this graph with a horizontal line. So we would say there is no inverse sine function. Well, wait a minute. This whole section is on the inverse sine function, and we just said there isn't one. How can that be? Well, what if we do this little trick like we did with the parabola, and we restrict the domain values? Okay, we took this original parabola and we said, well, if we limit the domain, then we will have a function where its inverse will be a function. And that's exactly what we're going to do with sine. We're going to restrict the domain so that it's only the x values between negative pi over 2 and positive pi over 2. So we're basically going to cut off the graph on either side of these two x values, and our domain will be the range of numbers in between. Okay, now this is still a function, and its inverse will be a function. So the way we can have an inverse sine function is if we restrict the domain on sine. Okay, and so next slide, I just want to point out a couple of things, and then we'll move on to cosine. This number that you see as an input for the inverse sine function has to be between -1 and +1. All right, so let me just make that statement again that I made earlier in this lesson. The range of a function, okay, range means the y, and here we're looking at sine. The range of the sine function is between the numbers -1 and +1. Well, that becomes the domain for inverse sine. Okay, remember that? We mentioned that earlier. The range of a function becomes the domain of its inverse, and that's also true for the range. So let's go back over. We restricted the domain of sine so that we could have an inverse function. So here's our restricted domain. That becomes the range of inverse sine. Range, of course, you can relate to y. All right, so let me just bottom line this for you. If you have a number here, y equals inverse sine of some number, let's say 2. Well, that is not obviously in this domain. So if you were to plug that into your calculator, inverse sine 2, you're going to get something like domain error or syntax error, probably say domain error, because 2 obviously isn't in this range of numbers. So for inverse sine, you're dealing with an input that is between -1 and +1 inclusive. And I hope based on the graph you can understand where those numbers come from. Your output will be some angle, and we're going to talk more about this in depth, but in radians it'll be an angle between -pi/2 and +pi/2. Alright, so we're just, again, we're laying some groundwork. If you're not sure what's going on yet, hold on. I think we're going to make all of this make sense when we start doing some actual homework problems. Alright, let's jump over to cosine. Same idea. Here is the cosine graph in red. In its entirety, we would have to say that the inverse cosine is not a function because it would not pass the horizontal line test. But if we restricted the domain so that it's only between 0 and pi, and I just shaded in green the part of the graph that would be included in this domain from 0 to pi, then that part of the graph would pass the horizontal line test. Therefore, that part would represent cosine that does have an inverse. Okay? So in order to have inverse cosine, we're going to have to restrict the domain of cosine. And here it is. It's between 0 and pi. Just a little different than sine. The input for cosine isn't any different. Notice how the range is still the same. The range for sine was between -1 and +1. That's still true for cosine. So that means that's going to be the domain for inverse cosine. The range, however, is a little different because the restricted domain for cosine is a little different than what it was for sine. So remember, the domain of cosine becomes the range for inverse cosine. So now when we do inverse cosine, we're looking for an angle measurement that's between 0 and pi in radians. Okay, and once again, to be defined, to be able to have an inverse cosine, we're going to need an input that's between -1 and +1. If you're asked to do inverse cosine -3, it's not going to be possible. Your calculator is going to spit that out and say domain error. This number has to fall within this range. Okay, quick look at the tangent function. I think I've drawn this for you before. We've talked about why we need these asymptote lines, because there are certain places, actually odd multiples of pi, where it's undefined. These are places where we would be trying to divide by 0. And so therefore we cannot let tangent, our graph of tangent, go through those places, because those are off limits. In other words, they're undefined areas. Okay, so if we took this entire graph in its entirety, and once again, same concept, if we use the horizontal line test, we would say that there is no inverse tangent function. But if we restrict the domain so that we only took this piece between -pi/2 and +pi/2, this one piece would pass the horizontal line test. Therefore, this would represent a graph that would have an inverse. All right, so much the same line of thinking that we dealt with sine and cosine. All right, so let me just run through this with you, and then we'll get specific. The input for inverse tangent is all real numbers, because the range for tangent, if you can tell, is all real numbers. Notice how along the y-axis, I'm traveling forever and ever up, I'm traveling forever and ever down. Okay, so the range for tangent becomes the domain for inverse tangent. And the domain for tangent between -pi/2 and +pi/2 becomes the range for inverse tangent. Okay, I think that's enough groundwork. We've laid a good foundation. Now let's jump into some of your actual homework problems, and we'll see if we can help you do these successfully. So the first block of problems, 13 through 24, the instructions just say find the exact value of each expression. Don't know why I put a question mark there. Find the exact value of each expression. Okay, let me draw a little comparison, contrast with what we were doing in chapter 7 versus what we're going to be doing now in this section 8.1. In chapter 7, you would be given a problem sort of like this, and you did this on your test. You would answer a question like, what is sine 30 degrees? And if you were looking at the unit circle, you would say sine, of course, relates to the y coordinate of the point on the unit circle that relates to 30 degrees. So you were given an angle measurement. It was up to you to find the ordered pair, the point of the ordered pair that represented either sine or cosine, or maybe you had to do some calculation with tangents, sine divided by cosine. But anyway, here my answer would be obviously 1/2. So you were given an angle, you were to find the ordered pair or the ratio. Well, in this lesson, you're actually finding the angle given sine, cosine, or tangent. So it's really a reversal in your thinking. Instead of being given the angle, now you're actually trying to find the angle. But if you have a unit circle, it makes it pretty easy to do. So for letter A, it says, what is inverse sine 1? It's like you're answering this question. What angle, now again, this is going to be in radians. What angle in radians has sine 1 in the range between negative pi over 2 and pi over 2? Remember, that is always the range for sine. We just established that just a little bit ago in some previous slides. So let me make this connection the way it's presented here in the range and the way you're looking at the unit circle when it comes to sine. For sine, you're going to get your answer from the right half of the unit circle. Just the right half. That's another way of saying between negative pi over 2, okay, that would be here, this bottom quadrant, and positive pi over 2 would be over here, this top right quadrant. Okay, inverse sine answers exist on the right half of the unit circle only, period, because that's the range of inverse sine. Okay, so let me show you how to get the answer for inverse sine 1. Okay, no calculators in this section. Just use your unit circle. All right, so again, we're looking for y coordinate 1, and let's see if we can find y coordinate 1 on the right half of the unit circle, and it's pretty obvious. Here we have y coordinate 1. Remember, sine relates to the y coordinate, and so again, we're looking for an angle measurement. It's a little different than what you're doing before. The angle measurement that would give us a y coordinate of 1 would be pi over 2. So my answer for letter A would be pi over 2. Okay, letter B. Once again, train yourself when you're doing inverse sine, cosine, or tangent. Train yourself to basically ask this question. What angle has sine negative 1/2 on the right side of the unit circle? Okay, so again, look for y coordinate, negative 1/2. I found it. Now, be careful, because if you're looking strictly at the unit circle, you might be tempted to call this 11 pi over 6. All right, but again, the domain is from negative pi over 2 to pi over 2. So basically what you're doing is, if you go up, that's pi over 6, pi over 4, pi over 3. And when you go down, that's negative pi over 6, negative pi over 4, negative pi over 3. Okay, so for negative 1/2, which is right here, I'm going to go down, and that's going to be negative pi over 6. So your answer for inverse sine has to be a degree in radians between negative pi over 2 and positive pi over 2. Or I like to think of it as the right half of the unit circle. Okay, let's try letter C. This says inverse tangent of 1, and putting it in question form, what angle in radians has tangent 1? And for tangent, it's like sine. You're looking at the right half of the unit circle. Sine and tangent are the same when it comes to their range. Cosine's going to be a little different. Okay, so tangent, remember, you could think of it as sine over cosine. To get 1, that means that we're going to have sine and cosine are the same, because any number divided by itself is 1, and it's got to be positive 1. So the only way to make that happen is if I do these ordered pairs, sine over cosine, I'm going to get positive 1. And the angle measurement is going to be pi over 4. If I had gone down here to negative pi over 4, that would have given me negative 1, of course. So the correct answer has to be positive pi over 4. Okay, now let's talk about cosine. We've talked about sine and tangent using the right half of the unit circle, because that's the way the range is described. Cosine's range is described, remember, as between 0 and pi. We talked about that earlier when we were looking at the graph and the restricted domain. Between 0 and pi is the range. Okay, so that means basically when you're talking about the unit circle, you're dealing with the top half. So cosine is different from sine and tangent. You're going to be dealing with you're going to be finding an angle measurement. If it exists, it'll be in the top half of the unit circle. So cosine, remember, relates to if you're talking about ordered pairs, it relates to the x-coordinate of an ordered pair. So I'm looking for an ordered pair that has x of 0, cosine 0, and that's right here. And that would be the angle in radians. It would be pi over 2. All right, this means inverse cosine. I'm looking for an angle in radians that has x-coordinate negative root 2 over 2. And again, if you're looking at the unit circle, these are really pretty easy. You just need to make sure you're looking in the right place. All right, so here I have x-coordinate negative root 2 over 2, and that is identified as the angle 3 pi over 4. Okay, very good. Let's try another one. Again, inverse cosine, and I'll just put it in a question for you. What angle in radians has cosine negative root 3 over 2, and it's got to be in this range? In other words, this is describing the top half of the unit circle between 0 and pi. All right, so x-coordinate negative root 3 over 2, that's pretty obvious. That's right here, and that's the angle 5 pi over 6. Okay, and one more in this block of problems. This is inverse tangent negative square root of 3. All right, so we got to change our focus a little bit. Now for tangent and for sine, you're looking right half of the unit circle only. Okay, negative square root of 3. Well, one thing you can remember, if it's a negative tangent, it's got to be down here, because sine over cosine, one of them has to be positive, the other has to be negative. They're both positive in quadrant 1. So we know we're going to find our answer. It's going to be one of these radian degrees down here in quadrant 4. And the way to get negative root 3 is if we do negative root 3 over 2 divided by 1 over 2. Remember, tangent is sine over cosine, or y over x. And something to remember with these complex fractions, if the denominators of the complex fractions are the same, you can basically just cancel them. And you end up with negative root 3 over 1, which is negative root 3. And that angle, remember, don't look at this and say that's 5 pi over 3. You're starting here at 0, and this is like negative pi over 6, negative pi over 4, negative pi over 3. Okay, so the answer here is negative pi over 3. Another way to remember that is your answer has to be in this range, negative pi over 2, positive pi over 2. So if you put 5 pi over 3, that is not going to be in this range, and that will be incorrect. Okay, so that takes care of the first block of problems. Okay, now for the next block of problems, 25 through 36, I do want you to use a calculator. You'll have to use a calculator for these. For the first block of problems that I just finished, do not use a calculator, use your unit circle. And a really important note here, you need to make sure that your calculator mode is set to radians. Otherwise, you're going to get wrong answers, and I don't want that to happen to you. So go ahead and change your mode to radians if you haven't already. And pretty much, these will be pretty easy for you. You just need to know which buttons to push. So let's take a look at letter A. Now I'm using a scientific calculator like the ones I have in the classroom. So the way I'm going to do this, I'm going to do second sine. And you'll see the notation there, inverse sine on the screen. It's got the left parentheses. And now I'm just going to enter negative 1/4, negative 1 divided by 4, close parentheses. And the answer, rounded to 2 decimal places, is negative 0.25. And that would be my answer for letter A. Okay, letter B, this time we're going to do inverse cosine, so second cosine, and we'll put in the square root of 2, square root of 2, and then 2 is closed in parentheses, and then divided by 3, close parentheses, and we got to the nearest 2 decimal places, it'll be 1.08. Okay, now I want you to see what happens with letter C. Second sine, and then we're going to put in the square root of 3. And you get domain error, and that's supposed to happen because remember what the domain for inverse sine is, and that's also true for inverse cosine. It's got to be a number between -1 and +1. And the square root of 3 is, it's like 1.7, which doesn't fall within this area of numbers. I was going to say range of numbers. I didn't want to confuse you. It's the domain, but it doesn't fall within this set of numbers. Therefore, that is not possible for inverse sine. It's got to be an input taken from this set of numbers. Okay, so I think I've helped you with all of the problems that you're going to be asked to do for your assignment, and this is it. And we'll check these on Tuesday, and we'll take any questions you have at that time.